Okay, we're going on with Chapter 5, the laws of motion. Let's share the PowerPoint. In chapters 2 and 4, we discussed Chapter 2, we discussed motion in one dimension, and Chapter 4, we discussed motion in two dimensions and the equations of how you describe these particular motions. We weren't concerned with why the the changes in velocity or direction occurred. We just were able to write them down as equations. Well, in chapter 5, in the laws of motion, we're going to discuss why a particular object would change its direction or change its velocity. So the previous chapters have been uh, kinematics, um, motion and describing motion. Now we're going to be discussing dynamics, what causes these changes in acceleration, these changes in velocities, direction, or its speed. So we're going to learn that the cause is forces. So we're going to discuss the concept of force. So this figure shows 6 different forces. The top 3 are what we call contact forces. A person pulls on a spring, it causes a force. A young lady pulls a wagon, and the wagon accelerates. He's causing a force. A football player kicks a football, and it accelerates upward at an angle. He's applied a force. These are all contact forces. Now, the bottom 3 are all field forces. In other words, no contact is necessary. The first is the gravitational force felt by from one object being in the presence of another object. Now, these could be tiny uh, particles, or it could be like our sun and our moon. The sun and the earth, or the earth and the moon. They attract each other. That's why they orbit in nearly circular orbits. We'll learn later that they're elliptical orbits, but that's not much concern right now. In the second of that bottom figure, we have electric forces. We have a negative charge is attracted to the positive charge. The blue negative charge is attracted to the positive charge. If there were 2 positive charges, they would repel one another. And if we look at the F, we have a chunk of iron being attracted to the north side of a magnet. It would also be attracted to the south side of the magnet. If we happen to have 2 magnets, if we had a north and a south facing each other, they would attract each other. However, if we had either a north or a north or a south, they would repel. So there would be a force there. They don't even have to touch. You would feel if you were to try to put a north and a north together, you would feel resistance. There's a force between them. So let's take a look at continue the concept of force. There's a downward force F1 in A here that elongates the spring 1 centimeter. Now, if we were to have another force that was really twice the mass that caused the first force, it would elongate the spring to 2 centimeters. And if we put both of them on there, let's say there were 2 different masses, when we applied those 2 masses together in the same direction, the spring would elongate by 3 centimeters. Okay, now let's look what happens if you put, let's say we're just going to call it a 1 unit mass that causes a 1 centimeter deflection, and a 2 unit mass that causes a 2 centimeter deflection. If you were to put the 1 unit mass downward and the 2 unit mass to the side, or be pulling with the equivalent of that 2 unit mass, you'll see that the combination is 2.24 centimeters. It's not 3, as in the previous case. Why? Well, because you have to add these vectorially. So the magnitude, and within the absolute value sign, that should be F total, not F1. It's just a publisher error. So the total F, the total force, is the square root of the sum of the forces. You can see that there's a horizontal component, F2, and a vertical component, F1. And if you were to take the square root of the sum of the squares, you would end up with 2.25 units. And we can even determine the angle with which the overall system would slant. And you take the arc tangent of the 1 unit and divided by the 2 units, you get the tangent of 0.5, and you end up with 26.6 degrees. And that, with that ends our introductory discussion into the concept of force. And next we'll discuss Newton's first law and inertial frames.